All right, friends and neighbors, welcome back to another networking video. Well, this is kind of networking, kind of network math. The MD5 sum actually appears in places, far more regularly outside of networks, but there we go. So today we're going to talk about the MD5 sum. So what's an MD5 sum? Well, if we expand the acronym, it's a message digest number 5, calculation for data integrity. It is defined in RFC 1321. Now this goes all the way back to 1992, and what it does is it takes a message of some kind, and it can be of arbitrary length, it can even be 0, and then creates a fingerprint or a message digest of the input. Now this is really just a calculation. We're going to take a look at the calculation here. It's fairly involved. It's computationally straightforward, computationally easy to implement, but we're not going to actually do one in this particular video. But what you do is you complete an MD5 sum on the message or the document, and then that is going to be a signature that can be attached to a file. And it's the idea is that you have a fairly easy calculation that can be done, but one that represents a sort of a unique value for that particular document or that particular message. So we also sometimes call this an MD5 hash of a particular message or file. And then later on, there were some updates to RFC 1321 and RFC 6151. And we can see it's the updated security considerations for an MD5 message digest and the HMAC MD5. Now HMAC is the hashed message authentication code. So what is its purpose? Very commonly used to verify the integrity of the file. So one of the common uses that we see is that you're going to go get an ISO and you want to install an operating system. So a lot of sites will post, well, here's our MD5, right? So here's how you know that the file that you got is verified by us. Here's our calculation. You do the MD5 calculation, and you can get an MD5 sum tool out there. There's a million of them. There's also some command line tools available in Linux. And then you run the MD5 sum, and then you sort of compare what the two values are. You can also create an MD5 hash of a message. And if the two sides agree on how they're going to do it, then you create an MD5 hash on a message, then the receiver creates the same MD5 hash, and there you have it. So you can verify the authenticity of the message, but also maybe that it wasn't manipulated in transit. Now there are previous versions of the message digest algorithm, so MD4 is an example. And there was concern in the security community, especially among the RSA folks, that maybe MD4 was adopted a little too quickly. And so MD5 backs off a little bit in the sense that speed is important, but not as big an issue as it was with MD4. And there's an extra, we're going to see that there's a number of steps in the algorithm, and the calculation MD5 adds an extra one. Now, a fun fact about this particular RFC is that it was written by Ron Rivest of RSA fame. And so a lot of times when you're talking about security, you hear about the RSA algorithms. Well, that R in there is for Rivest or Rivest. So how does it work? Well, you grab your text, whatever it is, and you can even have zero length, but you have some number of bits. And then you're going to pad out the number of bits to be 64 bits shy of a multiple of 512. So modulo 448. And then what you're going to do is append a 64-bit length of the message before it was padded. And so that gives you 512. Now another way to look at 512 bits is that you have 16 32-bit words or 16 4-byte words, and so at the end your modulo 512 equals 0. So now you've organized this data into, you can think of it as chunks of 32 bits, and you got a whole bunch of those, right? Because the 32 bits are actually what we're going to send through the algorithm. Now, you've reorganized your data, and you've said, okay, I've got this nice block of, this nice rectangle of data that's 4 bytes wide and 16 rows long. And now you're going to run all of that data through what are called the auxiliary functions. And there they are right there, F, G, H, and I. And each step is going to take X, Y, and Z and put them through the functions. And we'll do a little bit more on that. But that's sort of how you organize it. So the very first part of this is that you've got to organize the data into a format that can be sent through the aux functions. So X, Y, and Z in this case are 3 32-bit words. So your first 3 lines, you can think of it that way. You've got this chunk of data that's 32 bits wide and 16 rows long, and you're going to grab 3 of those, right? And so then you feed them into our functions. And so round 1 is going to be taking A, B, C, and then running them through the formula as you see in round 1 there. Now this is, more than you could do in a YouTube video, but you can see that in round 1 you do a particular operation, and the function that you're calling, the aux function, that's the main part of that, is going to be F. And then you go to round 2 and the main function is going to be G. And then round 3 is H and round 4 is I. Now, what is maybe worth knowing here is that F, G, H, and I are logic functions, right? So you can, when you look at those, you can read them as the ands and the intersections and the nots of various chunks of data or various 32-bit words. And so that's how you read those aux functions. Now, when you're all done, you want to get the final versions of A, B, C, and D, which is your actual MD5 sum. And you can see under the finally there, A is equal to A plus AA, or A and A, and B is equal to B plus B and B. And so there you have it. So that's the final version. So you run through all of these rounds, and you actually do this for every line of the code. So or every line of the data. You got to go through all of the data, and you run all of the rounds, and then you come up with the final versions of A, B, C, and D, and that's your actual MD5 sum. Now there's actual pseudocode and a C example in RFC 1321. So if you want to actually look at the MD5 sum, or if you want to have a fun programming project and do that yourself, you could, because the pseudocode is right there, and you pick the language you want to use. Now, closing up on the MD5 sum, here's another quote from the RFC's summary. It is conjectured that the difficulty of coming up with 2 messages that have the same message digest is on the order of 2 to the 64th power operations. So that means that what's the probability that 2 chunks of data are going to get the same MD5 sum? Now this is in 1992, okay, but you got 2 to the 64th power messages that you'd have to go through before you wound up with the same message digest. All right. Now, given that you had a message digest, what's the difficulty that you would have in working backwards and figuring out what it was? And that's on the order of 2 to the 128th power. So, at the time, MD5 algorithm was carefully scrutinized for weaknesses. But it was new, right? So, they don't know if they caught everything. But MD5 is still in use today, 30 years later. So it works pretty well, and there were no known sort of, catastrophic problems. There was the update, right? But it didn't obsolete the original RFC. Well, thanks for watching. Thanks for listening. Like and subscribe if this wasn't too much. And hey, may those packets always reach their destinations.